This is the general CNC electronics how-to video.
No, I just put it back on there.
Steppers. Frickin' dogs. Stepper drivers, e-stop, limit switches, and control board. Dog chewed up e-stops. Okay, well then, as always, like, subscribe, share, leave your comments. If you dislike, at least leave a comment and say why you disliked. Unless you're just a troll, then troll away. Alright, I want to run down some basic considerations for CNC wiring. First off is a multimeter. We want a multimeter with continuity checking, and that just makes for easy hands-free testing to see if you actually have a connection there. In this particular model, it has a little little picture of a speaker right around there, and I'm looking at this backwards. So anyway, the speaker setting is there, and again, autofocus is not working for me. So bear with me for 1 second. Okay, anyway, right there is a little symbol of a speaker. Show you how that works. It's pretty straightforward. Touch the two contacts together, and we get a beat. The display on the screen most of the time will not show 0, but it sure should, really. Close anyway. And then again, this particular meter has resistance, voltage DC, and those are the two straight lines. V, and then a squiggly line, which is volts AC. This particular meter also has temperature, transistor, PNP and NPN, amperage, AC, amperage DC, and capacitance, and actually hertz. So in all reality, for 20 bucks, this is a really good multi-purpose meter. Most of the actual functions, 99% of the people that buy it will never use. That includes myself. But like I said, for the money, it's nice. You can set it down, flip the screen up, actually see what you're doing. Alright, this is a micro limit switch. This is what's actually used to tell the machine when it's at its end. And pretty simple. When it's pushed down, it's in, and when it lets go, it's up. And they're positionally very accurate, so you'll get pretty good repeatability with it. And there's a common, a normally open, and a normally closed. So we're gonna probe this switch here real quick, and by doing that, I'm just gonna put the ground in there, and then I'm going to, and it will be written on the switch itself, but this is it's nice to show people the way it works. Alright, so that should be our normally closed. So when the switch is in the quote-unquote off position, that is on. So then when I activate the switch, we'll no longer get continuity on that one, and we'll get it on this one. Alright, so this would be our common leg. The furthest on the outside would be our normally closed, and the furthest on the inside will be our normally open. Alright, the way I like to wire switches, and the way I suggest people wire switches, is to run all 3 of the commons or all 6 of the commons, depending on if you're doing end stops and home switches, to 5-volt plus. Depending on your breakout board, you may get 5 volts out from the breakout board, or you may need to use a 5-volt DC adapter. If you do use a 5-volt DC adapter, make sure you test it with your multimeter on DC 20 V solid lines or straight lines 20, and make sure that you're getting right around 5 volts. If it's too much over 5 volts, a low ohm resistor may need to be put in series with the positive wire to jump that down. You don't want to put too much over 5 volts into the parallel port breakout boards. So all of your positives would go to one wire. All of your normally closed, that is when the switch is out, it has continuity going to it, those will all then go to the limit switch in this particular board. They're all nicely pinned out along this row. They will all go to the limit switch inputs on the board, and these are all screw terminal. So you just put the wire going into it, and these are these actually have 2 contactors on each one of them. Some of them just have a common, and then the rest of them. And I'll have to, and for this particular board, I'll actually have to do 5 minutes. I would have to actually do 5 minutes of testing to see exactly which pin is the active pin and which pin is the quote-unquote common pin. And these also actually all have pull-up resistors on it to limit the current actually going into the board. Okay, anyway, so what that does is that will make it so that there's a 5-volt current going, 5 volts and a small amount of current going through all the switches all the time. The benefit to that is when this contact is actually stopped, the electricity stops going through all 3 switches. Again, the benefit is that if a wire is inadvertently cut, the switches will trigger to the stop position. That's going to provide a safety net, so that and a lot of people do wire these to the normally open position, so that when the switch is triggered, it's giving 5-volt power. The problem with that is if the wire is cut or there's a bad connection and you don't know it, it's gonna run your machine into something. It's not gonna be good. Your machine will keep going because there's a wire cut and it can't get that 5 volts. At least this way, when the voltage is cut, it's done and over. So that's okay. So just for and just for sake of being completely complete, I guess. Yeah, that sounds right. My English is good. For sake of completeness, when we're using it this way in the software, we're going to have this on active high, and we're probably going to have to in software in some way, shape, or form have an inverted signal. That way the software knows that when it's off, when there's no signal, that's when I'm triggering my limit switch. And it'll be pretty easy to tell which is which, because, you know, as soon as you turn the machine on or whatever, you run the control software without the motors and stuff hooked up, and all limit switches are triggered and there's no triggering. So these will be run active high, and it makes sense because active high means voltage in. So along the same lines of continuity, this is a limit switch, or not a limit switch, I'm sorry, an e-stop switch. Everybody that's running machines familiar with it. You push it in, twist it, and pop it out. The red button unscrews, and then you can unscrew the black, mount this through some panel or somewhere that it's easy to access when you're typically running your machine. It would not be a terrible idea to run 2 of these, and as you can see, it still pops out when everything is taken apart. And just go ahead and put it all back together. Again, it would not be a terrible idea to have 2 of these on larger machines, one for each side of the machine, especially on the larger type machines. And again, same situation. These have a normally closed, normally open contacts, and you can see that there's purple and there's blue. And it will say on it, but we're going to test here because my switch is in. So this is the normally closed, the purple, normally open is blue, and we got continuity. So that when the limit switches hit, those have power triggered to them. So, and there's no common between these. Like, there is no way that there is ever going to be electricity flowing from one side of this to the other side in any situation whatsoever. So that leaves the possibility to run these guys with 120 volts. You can run 120 volts, your line through here. In typical installations, that's going to be the black line coming out of your power socket, going into your power supplies for your stepper motors. They would run through this, and again, if we had 2 of these running, you would run it through here. So it'd be the black line going to the crap. Let's see. Oh, it even says right there NONC. So normally closed. So you'd be going from the black line, your power coming in, going to this one, and then going from here to the next one, and then going from the next one to the power supplies to tee off, or some type of junction controller. So yeah, we're limited on 4 gigabytes per movie clip here. So so I gotta the movie's gonna stop, and I'll have to go on to the next one. I can turn the bit rate down, but yeah, I'm a dirty smoker. Dirty smoker. You know what? I've been doing my best to get onto these electronic cigarettes, and they do work and everything, but it is what it is. Okay. So that's that guy. And again, no, that's not even that. That's not even all of that. Alright, so now the normally open side. What we would want to do, quite possibly on the normally open side, for full integration into the system, would be to run, man, focus seems just terrible. I don't know if it's me or if it's the new software I'm using or what, but it just doesn't seem good. So we got normally open. We got a 5 volts, the same it could be the same 5 volts that we're running to the limit switches. 5 volts in here. The 5 volts then comes out of here and then goes to the e-stop switch, and then the e-stop switch would be made active high, so that when this is pushed, it then stops the 120 volts going to the motor drives, and then takes that 120 volts then takes the 5 volts and puts that 5 volts to the e-stop. so that the controller can actually say, hey, there has been an e-stop, and then you'll get an e-stop flashing on your computer screen as well. So that's that. Alright. So now on to the stepper drivers themselves. This is a typical step driver. This may or may not be one similar to what you have or something to that effect, but it is a pretty typical step driver. Yeah, I'm really not too pleased with the whole focusing today. Alright, so and they're wired pretty simply. You got a motor and your power connection. On this particular model, they're on the same removable plug unit. And I'll show you the motor connections here in just a second. But that's DC voltage, and it gives you the voltage. 48 volts is probably going to be nominal, 48 or 36 volts depending on the driver, 24 or 12 depending on the driver, really. This is the enable. The enable for these, almost all drivers that I've run across are active low, which means when there's no connection made to this guy whatsoever, actually I should say almost active off, because if there's no connection made to this enable pin, it works. The only time the driver is going to disable is when you put a 5 volt supply to these guys. So it could actually, again, just for sake of thoroughness, you could take the 5 volts from here and then run it into that. It would have to be run in parallel, so you'd need a separate wire going to here for the enable plus, and then the enable minus would then go to ground, whereas in this one going to the motor control, or the step control board, the actual breakout board would go not to ground, it'd go to just a straight pin in. Okay, so and then there's the actual pulsing and direction. On the actual board here, and I'll have to get proper pinouts for this guy. This guy is pretty nice because it does have little tiny red LEDs to tell you when you're actually making your pulsar move. It has 5 volts input or USB powered input. The actual, and again, these aren't, on this particular one, they're not totally intuitive on what these are, but this is obviously it's XN, XD, XS, XE. So let's just assume, and this may be true, may not be true, the obviously the X, Y, Z, and A are for the different axes. So X-axis, Y-axis, Z-axis, A-axis, and then the N, D, S, and E. So let's say enable, let's say signal, let's say direction, and then let's N is, I don't know, maybe neutral. Again, I'll have to do a little bit of digging and figure that out. I have all that down. It's actually, this board has been ran for testing purposes to make sure everything functions properly, and I have that information out in the shop. But let's say that it is truly enable, which we won't use because enable on this guy is going to be a ground, and almost always enable on these boards is, or I'm sorry, enable on this guy would have to be a 5 volts, and almost always enable on these guys is grounded. All right, so again, where we and sorry if I recover something I already did. This has been about 20 or 30 minutes now since the last one stopped. So on the driver board, there's X neutral, X direction, X step, and X enable. Again, as explained before, the X enable won't be used. The X step will go to the PLS plus. The XD will go to the DIR plus, and then the DIRN or DIR minus and the PLS minus will get jumpered together, and then they'll go to ground. And then the settings in the software will then be for positive pulse output, and they'll also be set for and then it'll kind of depend on how you actually want to go about switching motor directions in case you have the wrong motor direction. Alright, so real quick here, motor testing. I know that the coils on this, and there's 2 coils on this particular motor, are black, green, red, and blue. And I can verify that with the continuity on the tester. You'll only have continuity between coils as they're electrically isolated. As you can see, I'll go take the black one that I now got on blue coil, and I'll just kind of run over red, nothing, and blue, nothing. So we only have continuity on a coil per wires. It does not matter which wire goes to the negative and positive, so it can be on this particular one it's green and black, red, blue, so it doesn't matter if black is on positive and green's on negative, or green's on positive and black's on negative. It also doesn't matter if green is on, the green black is B or green black is A. It will affect the rotational direction of the motor though. So if you find after you get it set up and there's a couple of, and you move a couple of steps and it's not moving the right direction, you can either change the direction pulsing in the software. So if direction is positive enabled, you can switch it to negative enabled in the software, and it'll switch the rotational direction just by doing that, switching that one pin definition in the software, whether it's Mach 3 or EMC or whatever it is that you're using. Or you can simply switch the coil pairs around. I personally like to run all my coil pairs the same. So green and black will always be B, red and blue will always be A, and then if there's an issue with motor direction, I switch that in the software. And there's a lot to cover in the software. That's actually best left for forums and specific questions, because the software does get very lubricated very quick. Okay, main thing here is never ever ever put power to this driver, or really any other driver for that matter, without having a motor attached properly. Alright, and then real quick on this particular unit, there's current limiting micro switches right here and step micro switches. Those correspond to the tables on the back here. So it's micro steps and micro steps and current. And then pin 4 or switch 4 is for half power mode, when it actually doesn't have step or direction pulse sent to it after so long, and it's actually measured in milliseconds, so it's very fast. If there's no step direction sent to it, it drops to half current for holding mode. That really shouldn't be too big of an issue with most setups. You can run it in half mode, and most of the time for the smaller motors that I ship out, 3.1 to 3.1 amps is going to be about the max you want to put into the motors. You could actually move it down to 2.5 RMS and 3.5 max, and leave that jumper 4 to full current. I think that about covers it for the basics of the electronics, the very basics. I'll try to get another video up shortly, within the next day or two, on actual soldering basics and the use of heat shrink, and why we don't like crimp style connectors. Okay, thank you. I hope you enjoy this. As always, make sure you leave a comment, a like, a dislike, I guess. But if you leave a dislike, make sure you let me know why, so I can change something. Unless you're just being, you know, a troll, then troll away. Alright, have a good day.